And again, we're getting into this idea of the 3D representations of things. Okay? You're going to have to go sign in, Thomas. Okay, so the 3D representation of things and using trig in that 3D setting. So only solving for side lengths and things in these compound triangles, which you can see here, right? So the first one here, a compound triangle, what I mean by that is just like a triangle within a triangle. Okay, or breaking the triangle up into a couple pieces. You gotta go sign in. Okay. Sorry. Okay. So, what I'm looking for in this question is that theta. I don't know if we can clearly see that or not. It's just down in here. Now, theta is not this angle. It is just this one. Okay, but the problem is I'm not provided enough information on that smaller triangle here to solve for theta. Everyone in agreement? Everyone agree? Yep. Okay, so what is it you think you need in order to be able to solve for theta in that pink triangle that's there? Gabe?
The technical adjacent.
Oh, good, buddy. Yeah. I need this side length here. Right? And if this is the angle I'm interested in, then that's going to be the opposite side length, right? Okay, so I need that adjacent side length. So how might I get that? Done? Yeah, just by that. So if you're looking at, sometimes like with these questions, it just requires you to like look at it from a different perspective, right? You've got that big green triangle there. Okay, what I can find is this piece here, right? So, I'm gonna do that. So, triangles poorly labeled. We always usually say that C is gonna be the hypotenuse, right? And that whole component, side length B on the bottom, let me see this, side length B from here to here, is gonna be the 6 plus 9 meters, or centimeters, sorry, for a total of 15 centimeters there, side length B. Okay, so you know the hypotenuse, you know side length B, so let's solve for that adjacent side length. Okay, so we're gonna go a squared plus b squared is equal to c squared, and so I'm gonna have 25 squared as the hypotenuse, and 15 squared for b, and a is gonna be the side length that I'm looking for. Is that okay? This is just Pythagorean theorem, which makes a squared gonna equal 25 squared. What's 25 squared? Do we know that? Top there. 625. 625 minus 225.
400.
Yeah, sorry. So a squared is gonna be equal to 400. So square root both sides. It's gonna be 20, right? Is everyone okay? Alright, so now that I know that adjacent side length, if you really wanted to, you could just, I don't know, for your own sake, you could just redraw the triangle. You don't have to. But maybe helps in what it is we're doing. You have 9 centimeters there. And now we know this is 20, and this is the angle I'm looking for, theta. You see that? Oh, this is 90 degrees, sorry. So if I'm interested in the angle, if this is going to still be opposite and this is adjacent, and this is hypotenuse, and I write out SOHCAHTOA, which side length do I not have any information on?
Adjacent.
No, I know the adjacent now.
Oh, hypotenuse.
Hypotenuse, yeah. So I don't know anything about the hypotenuse. It's not asking me for it. And so I'm just going to scratch out the trig ratios that involve h, the hypotenuse. Because I know I'm not going to use those ones, right? So that's gone and that's gone. That leaves me with tangent. Because tangent's the one that doesn't involve using the hypotenuse, right? So I'm going to go the tan of theta is going to equal opposite over adjacent, which is 9 over 20. So theta, the answer to this question should be the tan inverse of 9 by 20, which, if I'm not mistaken, should be 24 degrees. Everybody okay? Okay, so that's your first taste. Like, these can get a little tricky because they're like little puzzles, right? Sometimes you got to identify what it is the question's asking for, and then as well, what information's been provided to you in another part of the question, and kind of backfill to get to where you need to get to. Okay? Everybody okay? We'll do the next one. So, in this question, it wants us to solve for side length EC, so this green highlighted component. Okay? The tricky bit is going to be figuring out what information you can find that's going to be useful in order to get towards that. Right? So, I think the first thing we should do, does anybody have any ideas? You can find side length C. Oh, sorry. I'm sorry. Not side length C. Side length C. Angle C. Okay, if I find this, why might I be interested in that little component down in like angle C? We'll call it theta. Duh.
Because you can find the angle and then like find the remaining degrees of 180 for the other angle.
Yeah, so if I find theta, then I could find what we call phi. Right? From here to here, we know is how many degrees? 180. So if I go 180, 180 minus theta, minus that 91.7, that's going to equal that phi angle. Everybody see that? Okay, so that's what I'm going to do. Again, if I'm standing here, this is going to be opposite, this is adjacent, and I, again, don't know anything about the hypotenuse. So I'm picking tangent, because tangent is opposite over adjacent. Right? So I'm going to go tan of theta is going to equal opposite 21.3 divided by 19.4. And so theta in this part is going to be tan inverse of those numbers. So theta should be 47.7 degrees. You can check that with your calculator in case you go through.
Which one are you looking?
What do you mean?
That numbers upside down. Oh no, because I mistaked it for this one. I had it wrong when you just sent it to this. Look how it's supposed to. Whoops. So
Or okay?
That's why I did like this. That's the degree.
Okay.
Oh yes.
So to get phi,
Never mind. He's looking at that.
okay, I now know theta. Theta is 47.7. So if I go 180, take away the 47.7, minus 91.7, that should equal the phi angle in here. So phi is going to equal 40.6. So now I know in here, this is going to be okay, I got one step left. The question asked me for side length EC, that green highlighted component. So if I stand at that 40.6 angle, and I look, if I'm standing here, I look across, that's going to be opposite. I don't know anything about adjacent, but I don't really care about it because in the context of this question, it's not really asking me about it. I care about the green component, which is going to be the hypotenuse. Okay, so I'm just going to write out, sorry, this would be number 2, and number 3 would be in triangle CDE, we're going to find side length D or EC, side length EC. Okay, I'm going to do that with, or I'll write it like this. Maybe some of you like it like this, I'm not sure. Save some space too. Okay, so I don't know anything about what side length, nor do I care about it. In the red writing, what side length do I not care about? Side length CD, so that would have been the one that's labeled adjacent, right? So because I don't care about the side length that's labeled adjacent, I'm going to scratch out everything that has an A in it, because I'm not going to use it, which leaves me with sine. Sine theta, or sorry, be sine of 46.6.
I thought it was 40.
Yeah. This is what happens when there's 4,000 conversations going on in the classroom while I'm trying to think. Right? We've got opposite is going to be the 23.5 divided by the hypotenuse. So we've got a bit of a problem. Sorry, I'll swing that up there. I should have done that initially. What's the problem? Gabe?
The number is on the top and the variable's on the bottom.
Yeah, the thing I'm looking for is in the denominator of the fraction. So what you're going to have to do here in order to solve this, it'd be like kind of like cross multiplying, right? And then solving. So you're going to have to multiply by hypotenuse on both sides. And here's where you end up. I'll write where you end up in a sec. So you multiply by hypotenuse on both sides, and you're going to get everyone agree? It's not a huge problem, but it is just an annoyance more than anything, I think, right? Having that unknown thing in the denominator of the ratio is a bit of a problem. Not a big one, but again, an annoyance, not a problem. So how would I get the hypotenuse by itself now in that blue line? Gabe?
Divide both sides by sine 40.6.
Yeah, you divide both sides by sine, 40.6. Right? Sine 40s drop out. You're left with the hypotenuse. And when you type that in, you should end up with something like just make sure you can get that number, because if you can't, that's a separate issue. In addition, like, these are separate skills. Being able to like get an answer at the end of a question is a separate skill from being able to do all the work to get there. Just make sure you can type that in and get that number. Okay. We've got a problem here with this next question, I think. This is maybe again, you've done this before, it's just a little review. So here, let's try and draw triangle X, Y, and Z. Okay? So here's what we got. So what's the problem with this question? It's not, again, not a major problem. You have a tool to deal with this, but Gabe,
It's not a right angle triangle.
yeah, you can't definitively say that this is a right angled triangle based on what's been provided to you in the question. So you can't draw it as such. And that means you can't use what to solve this? There's a list of things you can't use now. You can't use SOHCAHTOA, because SOHCAHTOA, or the trig ratios, are only for 90-degree triangles. And what else can't you use? Sine law?
Oh no, it's sine.
What do you mean by sine law? You mean like the actual sine law that we were talking about last year? Or are you talking sine as opposite over hypotenuse and confusing the idea?
Sine law.
All right. Jacob's right. We can't use sine law either, because we don't know what, Jacob?
Any inside angle?
We don't know any angles either. There's one, no, but that wasn't the answer I was looking for. That's why, Jacob, I got a little sidetracked there. What's another thing I can't use? Nicholas?
Pythagorean theorem.
Can't use Pythagorean theorem either. Because Pythagorean theorem is only good for right angle triangles. So from our list, no SOHCAHTOA, no Pythagorean theorem, can't use sine law. What's left? Gabe?
Cosine
Yeah.
sandwich.
Well, it's cosine law, but there's no sandwich there. Right? Remember, a cos-law sandwich requires you to have an angle. And more specifically, a contained angle between two side lengths. Which I don't have any angles. So what's that mean? I gotta use cosine law, but for angles. What is that? Do you remember what that is? Okay, I'm gonna hit pause on that question for a second. We're gonna go down below, and I'm gonna show you something that I think, well, maybe you actually haven't seen this before. I don't know. What is this? this cosine law, but how is it written? Gabe?
It's written to a specific angle and to solve for a specific side.
Yeah, so the answer I was looking for is it's written in a way that solves for side lengths. But it can be manipulated to get the angle. Everyone agree? So I'm going to take this one, this is the C, and I'm just going to rearrange it for a sec. All right? So what I'm going to do is take this equation and rearrange it to get at angle C. Right? So C squared minus A squared minus B squared has to equal negative 2BC cosine C. Everyone agree? Sorry. Cos C. Everybody good? Remember, I'm after this. I want the version of the equation that gives me C, angle C is equal to a bunch of stuff. So that's what I'm doing. So what's next? How is the negative 2AB attached to the cosine? Gabe?
Multiplication.
Yeah, so how do I get rid of it?
Division.
You divide both sides by negative 2AB. So now the negative 2AB's drop out. We're left at the cosine of C is going to equal C squared minus A squared minus B squared, all divided by negative 2AB. Is C isolated?
You could inverse both sides by cosine.
Yeah, I remember yesterday, in order to get C by itself, I'd divide both sides by cos, right? And then I could subsequently bring cosine up by making its exponent negative, which is where that cos inverse has come from, right? So the actual answer here, angle C, we can solve for angle C using cos inverse of C squared minus A squared minus B squared, all divided by negative 2AB. Is that okay? Did you sign in? Yeah, here, come get the lesson. Okay, so let's go back now, because obviously the thing I'm looking for, remember when we're solving for triangles, the rule from yesterday didn't change. We're still looking like there's 6 things to solve for in a triangle. All 3 side lengths have been provided to me in this question. So it's obviously not a side length that I'm looking for because I already know 3 of them, which is why I've gone through this process of getting that equation. So it asks for us to find angle Z. So this one. Right? So here's the reality of, like, I don't really care what you do now, right? I don't care if you change the labels of these triangles to fit your cosine law. Why would I do that? Because I've already isolated for C. So here, I'm going to call this C and that little c. And then the other 2 don't matter. Is everyone good? I can call this A, which makes this little a. And this is capital B, and this is going to make this little b. The reason why I do that is because now I can just like memorize one form of this cosine law and change my triangle to match that whatever of the 3 I've memorized. So I'm not having to throw X, Y, and Z in there and try and confuse myself or put something in the wrong spot, right? You really just need to know one of these, and then you can isolate to get the other one if you didn't memorize it, and then just change your triangle to fit what it is they're looking for. So here, let's use the equation now. Angle C, or what would be angle Z, is going to equal C squared, which is 17 squared. Oh, sorry, let's write the cos inverse. Move that down. is 10. What's everybody get? Sometimes the problem too is when don't worry about how you've drawn your question, because there's some what's the word I'm looking for? Some variance in the way that everybody draws their triangles, right? And so don't worry about the fact that your answer maybe doesn't match the way that you've drawn your triangle. You've just drawn some triangle on your page. Does anybody get an answer? This one I don't actually have an answer for, so you guys are gonna have to help me with it.
I mean, I got negative 0.7.
You gotta go cos inverse of that though, right?
Yeah, I know.
Okay. Okay, Robbie?
141.37 degrees.
Okay. 141 point, let's call it 4 degrees.
Or why not?
Can anybody confirm that number?
Yeah.
All right, so that seems okay.
Yep.
Okay, if you have a scientific calculator, you can type this like, you should be able just to build this component right here in the scientific calculator with enough brackets, right? Hit equals, and then go cos inverse answer. You just have to be careful. You got to use brackets. You got to use lots of brackets. The more, the better. Yeah, we just didn't draw. I had no idea what the angle was going to come out to be, right? I'm just using the picture to help me organize my thoughts and put information on there, right? I'm not going to take off marks because your triangle doesn't match your answer. You don't know the answer from the beginning. You could fix the triangle after if I asked you to. But. Is everybody okay? All right. Turn it over. Got some more problems.
Hi. Oh. Oh. Yeah, you did. You wrote.
Okay. So it says here, 3 towns, A, B, C, are located so that B is 25 kilometers from A. So B is located 25 kilometers from A. And then C is 34 kilometers from A. And again, don't worry about the accuracy of your diagram. You're just putting information on something that you could then use to solve for real stuff, right? Angle A is 110 degrees. It's looking for the distance between towns B and C. What do we got on our page right now? We have a triangle. What information is on said triangle? Gabe?
We have a side angle and another side.
We have a side, contained angle, and a side length. Do you know what you call that?
No. I didn't ask for it. Just didn't. Oh. No, I didn't.
It's a coleslaw sandwich. Did you know a couple years ago somebody actually made me a coleslaw sandwich? Couldn't eat it. Could not do that. Could not do it.
You don't like coleslaw?
No, I'm not a fan of coleslaw, let alone soggy bread. Not a fan, if you can imagine.
And it probably didn't have enough mayo on it, or cheese or something like that.
Okay, so coleslaw, we need to figure out if this is what I'm looking for. You could go back to the top side of the page or flip it back over. Gonna use that. Okay, don't waste your time in a test typing this as individual components and taking like 7 lines to get an answer. Get yourself a scientific calculator, type it all in 1 line and hit equals, and then square root the answer. Should be done in 2 minutes after you've drawn the picture, right? So by that I mean we should be able to just type all this stuff in. Okay, the reason why I'm saying type all this in as one big thing is because this what's the word I'm looking for? This behaves in a way that you don't think it does. This cos of 110. Why don't you all entertain me for a second and type in the cosine of 110? We're gonna actually get into why this happens the way it does in this course. But for right now, what's the cosine of 110? It's negative what?
0.34.
Okay, negative 0.3. I don't really care what the number is. The point is it's negative. Right? If this component is negative, then I have a negative and a negative. Can we see that? Which turns this whole second component, you're adding this whole second component to the first one. And if you try and do this in separate chunks and you forget to do that, adding, you're going to get the wrong answer. So, type this whole thing in. Avoid it being an issue. Type it all in your calculator with brackets. Hit equals. Should get some number, answer.
2,362.
Yeah. Okay, so you're going to get A is equal to the square root of whatever that answer is. But anyway, here.
7 million, something like that.
What did you say it was?
2,362.
2362. Any decimals?
4,342.
That's good, that's good. So A is equal to what? Square root of that number.
48.6.
I got an error.
Try it again. Don't put the brackets around the minus sign.
Oh, I did that.
Sorry. I was just illustrating that. Sorry. What about it? It's 2 seconds. Just fix it. You should be able to
It's
delete
not
them.
2 seconds.
You should be able to go with your arrows and delete the 2 brackets.
No, because I already pressed equals.
Go back. You can go back to previous equations. Hit up.
Wow.
We are right now.
I actually can't.
I never knew that's what Louisiana's do. Do you know that?
Can I lose my hair? Oh, but is this good? I feel my scalp moving now.
Okay. No therefore statement on the test. -1.
Whoa.
for word problems.
Okay. Word.
Anytime you have context on a problem, you got to put a therefore statement, right? If I just say solve for all the pieces, then you don't need therefore statements. But if, as soon as you see context, and by context I mean a word problem, you need to conclude your findings. Because how do I know you know that that answer that you just found is the distance from B to C, and not, for whatever reasons going on in your head, AC? You need to communicate your answers. You do that with the therefore statement. And it better be legible. Or -1. If I have to guess, how am I guessing?
Oh.
Wrong.
Why'd you put tens with the uppercase?
Because they're the vertices of the triangle, actually. So they, remember yesterday when we were labeling our triangles, we had the vertices as capital letters and the side lengths were lowercase. Right, yeah, oh yeah, that's right. She showed up late and didn't watch the video. Double whammy.
Yes, I did.
Okay, everybody okay?
You just always assume the worst of me.
That's right, that's right. You were here on time today, though.
Yeah,
That's good.
yeah. I skipped getting Mitchell's birthday present to be here. So.
Okay, the largest crater in Arizona, northern Arizona. Approximately 1.5 kilometers wide.
Your Mac is gonna sleep soon if you don't plug it into a power.
Yeah, thank you. Okay, the largest crater. Hey, are you guys done? Or you go have a conversation? Go, get out of here. Go, get out. See ya. Come back in 20 minutes. 10 minutes. Let me finish the question. 10 minutes. You can watch the video there. Okay. So the crater is approximately 1.5 kilometers wide. So what I'm going to do is go A and B. And this will be the width of the crater. So from one side of the crater, a weather plane is spotted with an angle of elevation of 45 degrees. I think this is a 3D one. So you got a plane up here. Sorry. Well, okay, so here. Where do airplanes fly? Up in the air. So here's what's happening, I think. Let me just think here for a second. I don't think I have the best picture here. So we got a plane in the sky. It's at the crater. One edge of it. I think this is where it is. I don't know.
Just because.
There's lines of sight. We can make it solid if you want. I had something else in my head when I began the question, like a representation of what was happening. Okay. Sorry, I had a different. I thought I was going to ask this something else at the beginning of this question. So sorry. The plane is flying above. Okay, sorry. Here, from here to here, let me rephrase this. This is the two AB. So the distance between AB, sorry, my bad. I had a different visualization in my head.
Okay.
So from A to B, it's 1.5 kilometers. Probably had something to do with the 4,000 conversations that were going on at the beginning of this question. That's the width of the crater. And what they're saying is like, on one side, you've got the person standing here. They see the airplane at an angle of elevation of 45 degrees. They then walk 1.5 kilometers to the other side of the crater. And they look up, 64 degrees of elevation. Or somebody else is on the other side or something. You got two buddies or whatever it is.
Standing still.
It could be a helicopter, who knows? So you got two buddies. They're 1.5 kilometers apart. They both look up and see an airplane. One sees the airplane at 45 degrees angle of elevation, and the other one sees it at 64.
That one's you. You couldn't know.
Okay, so from calculate the distances from the plane to each side of the crater. So it's looking for this and looking for this. Okay, so what do you want to use?
Side law.
Wait, here. This would be side length A. This is side length B. The plane could be side length or angle C, and side length C would be opposite of it.
It's red cup day.
Side law.
Yeah, I'd use sine law. How many times are we going to do sine law? Twice. Why twice? So I'm looking for two things. Use two good? I don't think you are. That's why I'm asking. There's your sine law. Okay, you can fill in your information. So sine of A, angle A is 45 degrees. Divided by side length A. I don't know that. Is equal to the sine of B over side length B. Oh, sorry, I know angle B.
What's the first one in brackets?
And then sine of C. What's the problem with this one though?
You don't know sine.
You don't know sine of C, but what?
Could you not find it?
You could find it. How could you find, and not sine of C, sorry. We're not finding sine of C. We're finding angle C.
Just do
Right.
180 minus.
Yeah, so I can find angle C by going 180 minus 45 minus 64. You should find that to be 71 degrees, I think, eh? Okay. So I can now fill in C as being 71. So here's what you can do now. If you haven't seen sine law in a while, you can scratch out one of these and ignore it for a second. You have, in this question, 4 things that you might not know at the beginning of the question, and then you filled in 3 of them. So now you can find the 4th. Does that make sense? Okay, so you can just do the math on this now, right? So I'm looking for B. To find it, I can do what is called cross multiplying, and I would get 1.5 times sine 64 has to equal B sine 71. And then to get B by itself, I would just divide both sides by sine 71.
Why do we just get rid of the A?
Because I'm not going to do too much at once. I'm just looking for one thing at a time. So I'm going to do A in a minute, but I'm just going to do one thing at once. One thing at a time. I'm going to do the exact same work to solve for B in a second. Or sorry, A in a second. right? So those drop out. So B is going to equal 1.5. And again, this is just turned into a calculator exercise now. The math's kind of done. So you should be able to type that in and get a number like, I'll tell you what it is, just make sure you can get it though. Is it 1.1?
1.425.
Okay, sorry, I got the wrong, I mixed up. My triangle's drawn different in my answers. So 1.5 kilometers, right?
You could also do just, since you already have sine 71 over 1.5, you just do sine 71 over 1.5, get your answer, and multiply both by b, and divide by.
Yeah, this is the reason, you're gonna get in the same spot, but that's the reason. Because you've got some, like some process to follow, right?
Yeah.
Okay, so that's how you get B, and then I can do the exact same work to get A. I'm just gonna go sine of 45 over A has to equal the sine of 71 by 1.5. Do the exact same work, and you'll find that A should equal 1.5 sine 45 divided by sine of 71. And again, just a calculator exercise, you should get that 1.1 for that one. Okay, so then at the very end, you write your therefore statements, and you're all good.